Can you let me know, did you try downloading the JASP app?
Yes, I have the app downloaded.
Okay, and what about the rest? You can keep yourself unmuted, that's fine.
Yes, I
for now.
also.
Okay, so were you able to transfer the data from Excel to JASP?
No.
Okay, so that is the first stumbling block that the students have when how to transfer the data from Excel to JASP. I'm going to show you something here. So let me just share the screen with you all for a second, and I'm going to show you something. Hold on, where do I? Okay, so this is the homework. Can you see the screen? Can you see this Excel sheet?
Yes.
So this is the homework you got, right? In your first JASP homework? Remember? Where
yes. On the video? Yeah.
Mm-hmm. So I asked you to calculate the mean, median, and standard deviation, and also create, I think, a frequency distribution table out of this data. So here is the gender of each participant, and then age, and then marital status, and then this is their creativity skill. Suppose I want you to find the mean creativity skill of male and female separately. And also suppose I want you to find the mean of the age of males and females separately. Anyway, so this is an Excel file. So first and foremost thing you need to do is, if you save this as, let me show you here. You need to save this as, let me just go to, I'm saving it in my downloads. So do you see this extension? Typically, if it is an Excel file, probably it will be saved as XLS, okay? Or Excel 97 to 2003. But what you need to do is, you need to save it as CSV, delimited, okay? This is the option you have to use for the file type. So then I'm going to save it. Yes. Okay. I already saved it earlier, so that's why it's giving me that particular message. Anyway, now this is saved as a CSV spreadsheet. Now my I have opened my JASP, and then I am going to open, and then I'll go to computer. I had saved my data in downloads, so I'll go to downloads, and then I will go to practice. See, if you share it as just Excel sheet, Excel with an XLS extension, you're not going to see it here. Even if you save it, you won't see it when you open it from JASP. However, if you save it as a CSV, delimited file type, then you will see it here in your saved list. Now I'm going to open this practice data for JASP, and I'm going to open. And this quickly transfers the data set to JASP. Now what I need to do is, I'll go to descriptives and then click descriptive statistics, and then here you see all these different columns. So do you see these three bubbles? For gender, gender is a group variable. Gender is like if you look at the column of gender, it's just M and F. So it is a categorical or a group variable. It doesn't have any numbers. So, or it is also called nominal variable. When the variable is nominal, so then you have to make sure that you have these three bubbles. The column that has numbers, that has numeric values, it has to have this scale variable. Okay, so and then again, marital status is another variable. It has 4 groups: divorced, married, I think unmarried. I think there are 3 or 4 you know, categories under marital status. Again, it is a nominal variable. It doesn't have any numeric, so you have to have this. You make sure that it has these 3 buttons showing. Okay, and this one is your creativity skill. Again, this creativity skill is a scale variable, so it has to show the scale. Anyway, so what I'm going to do is, suppose you wanted to show the creativity skill and age for male and female separately. So you bring this gender here to split the gender. So the moment you split the gender, you will see that it shows different, you know, different values, different. It divides the gender into 2 groups and shows the values separately. So here is the average number of females, average, not number, sorry. Here is the average, you know, skill, creativity skill for female, and this is the average age for female. And then again, here is the average creativity skill for male, and here is the average age for male. Similarly, say you want to just, you know, split it for marital status. So the moment you split it for marital status, it shows the average average creativity skill for divorce, for married, for single. Again, average age for divorce, married, and single. Average means, okay, it's the same thing. Here it shows the average, and then here, if you look at the value, it shows the standard deviation, and then here it is the minimum and maximum. So you want to go, you know, do a little more about it. Suppose you want to look at the frequency distribution table. You just click, you have to, typically it is unchecked. You just have to check it and then plot, okay? And then when you, the moment you click the plots, display. So here, you know what it is doing? It is showing separate plots because I have separated in terms of marital status. Suppose I don't want to split it. I bring it all here together, okay? Suppose I bring it all here, okay? Then it will show you the creativity skill for everyone. This is nothing but histogram, okay? This particular graph, and this is the plot. Here in JASP, it's called plot, but actually this is a histogram. And then, well, again, there is something called bar graph. So what is the difference between bar graph and a histogram? Bar graph, these bars are slightly separated from each other in a graph. But in a histogram, these bars are touching each other. That's the only difference. There is no other difference, okay? So here, this is the distribution plot for the creativity skill, and this is the distribution plot for the age. And then if you want like a combined, you know, mean, median, and everything, you just bring everything here, and then you will get the mean, median, and mode for everything together instead of, you know, splitting them. Okay, and the other thing is, here is the frequency distribution table. The frequency distribution table, the first column is the frequency, that is the number of participants under each condition. Under divorce condition, there were 4. Under married, there were 7. Single, 12. There is nobody missing in any of these groups. The groups, and then this is it shows the percentage, and this is the cumulative percentage. So when I ask you for a frequency distribution table, all you need to do is bring everything here and then click this frequency table box, and it shows you everything. And if you want to create plot a histogram, all you need to do is just click this. When you unclick this, it's gone. When you click this, it will give you this little histogram. And one more thing, if you click this statistics, here you'll see a lot of things, mean, median, mode. It also gives you, now it gives you not only the mean, it also gives you median, mode, standard deviation. As there are a lot of choices here. I typically ask for mean, median, and mode, and this is all you need to do. Also, one more thing I wanted to share with you was that, okay, we can do it later, but just in case you want to learn this, suppose I say that, okay, what is the correlation between the two scores? Say you want to, hold on, just remove the nominal variables and bring only the numerical data set on the right hand side. Suppose you want to see if there is a correlation between these two columns. All you need to do is here. You just click the correlation plot. Oops. Okay, and it will give you this correlation. Okay, and there is another place where you can actually do the correlation, and you don't need to go there at the moment because today we will be just focusing on mean, median, and mode, and then I'll show you the t-test, because I think I have given you a homework where you have to do the independent and independent group t-test and the repeated measures t-test. Now, do you have any question for this one?
No.
Okay, is this clear to all?
Yes, ma'am.
Okay, thank you. So now I will open a new data set, and that new data set is, first I'm going to start with repeated measures. Okay, so before we go for repeated versus independent group design, independent group measures, I want you to know the difference between the repeated measures t-test and the independent group t-test. So I'm going to just write it down here. Say independent group, independent t-test. So, and the repeated t-test. It is also called related t-test or paired t-test. Okay, this repeated measures t-test. I don't know what's written in your textbook because different textbooks write different. They have given different name to it, but it all means the same, repeated or say related t-test. Okay, now what is the difference? So in independent t-test, well, first of all, you use t-test to compare the means of two groups. Suppose you have two groups, say males and females. Say, I'll give you just an example. Say frequency of smiles that you see across gender. For example, say my hypothesis is that females, they smile more often than males, okay? So then probably I will go to a public place and I'll just look at how many, what is the frequency of smile for females versus males. Now I have two groups. Suppose I want to prove that there is a significant difference between the frequency of smiles between males and females. So, and for that, what you need to do is, if you want to show the significant difference between two groups, you have to conduct a t-test. Now, remember, in a t-test, there are two types of t-tests. One is independent t-test, and the other one is repeated measures t-test. Now, in independent t-test, there are two different groups, okay? Say there will be a data set for male, and then there's a separate data set for male, and then there's a separate data set for female, okay? So you'll have a column for male, and you'll have a whole big, bunch of numbers. So that is the data set for males, and then the next column will be female, which will have again another set of data. So when there are two different groups involved, then it is called independent, okay, because they are two independent categories, okay. And when there are two independent categories and you want to compare those two categories, you use independent t-test. Repeated measures t-test, sometimes say it won't really apply in this, in the case of gender, but suppose oftentimes we use pre-test, post-test for various reasons, for various interventions, whatever. In pre-test, post-test, what happens is it's the same group of participants. Suppose it's the same group of, say, you have a group of 20 patients who will undergo some sort of a special treatment. So what the investigator wants to see is that if there is a significant improvement in the patient's health after a certain intervention. So obviously, the pre-test, what the investigator will do, the investigator will record the symptoms of all the participants. Say you have like 5 participants, 1, 2, 3, 4, 5. It's the same 5 of same 5 participants, same group of 5 participants. First, you will record their symptoms, which is your pre-test, and then you will give them the intervention, and then in the post-test, it will be the same group of participants. You will again measure their signs and symptoms, and you'll have another set of data here. So in repeated or related t-test, what happens is it is the same group of participants that undergo two different sessions. And in independent group, what happens? It is two different groups of participants. Does it make sense to everyone?
Yes.
Okay. So if it makes sense to everyone, then I can move on to the statistical analysis part. So now, first, I'll start with the repeated measures example, how to conduct a repeated measures t-test. Repeated measures means this one, where the same group of participants will undergo two different situations. It is not always pre-test and post-test. It could be anything. It could be like some sort of training or something else. Maybe intervention 1 was given to the group like at time 1, and then the same group of participants received intervention 2 at time 2. As long as it is the same group of participants, it's going to be repeated or related measures t-test. So here is an example. So suppose you want to see the effects of the hours of sleep on the attention span. Okay, so here is the same group of participants. Okay, so these are, say, let me just so that you don't get confused, I will insert one more column, and I'll just call them as A, B, C, D, E, F, and G. So so what the investigator did, the investigator invited this group on day 1 and made them sleep for, say, for a short period of time, okay? And then gave these are basically their performance on some task, okay? And, how well they did in the task, how much they scored in the task. So low means they all were made to sleep, say, for about, say, 3 hours in a night, okay? And then moderate means they were made to sleep, say, 5 hours in the night, and then here, this group, they had like, say, 8 hours of sleep, okay? So what investigator did, it is the same group of participants On day 1, they came and the investigator observed them. They made them sleep for 3 hours and then gave them a task to complete. And they completed the task, and this is their score, everyone's score. And then after some time, again, the same group of participants were invited to another session. In that session, they were made to sleep for, say, 5 hours. And another test was given, similar. The test is not exactly the same, but it is the similar test and similar degree of difficulty, no difference. So, and here is the performance. And then on day 3, the same group of participants came and they had enough sleep and they performed. These are the scores. Now I want to conduct a repeated or related t-test for this group. So what I'm going to do is, first, let me just get rid of this here that I already have. I am going to click this. Okay, let me, I don't know if I saved this already. I want to just save it for, okay. Yes, I've just saved it. Now, do not forget to save it every time you make a change to this. So what I'm going to do is I'm going to open this and then go to download. Under download, it is repeated measures. I'm going to open this. Okay. And oops, hold on for a second. What happened? Did I not open this? Just a second. Okay, it's thinking, it's taking some time to open it. It is going to open at some point, I guess. Just give me a second. What happened? I don't know. Okay, it's still opening. Where did it go? It's my computer kind of. I'll go to download, repeated measures. Let me just check. Okay. It's taking some time to open. I'm not sure what happened. Oh, okay. Did it open here? Okay, it just opened it here. So now what I'm gonna do is so this is my data set. So remember, this is just the name of the participants, okay? And obviously this is not a part of your analysis. This is just for our information. So these are the 3 columns that we are going to use, and this is actually not required. They just came as something extra. We are not going to use them, but let it be here. It's okay. So make sure that these, this graph is correct. Whenever you see always make sure that whenever you have a numerical value, make sure to change it to scale, okay? This is the most important thing, because when you transfer it from Excel, it may come, it may randomly select any of the scales. So you have to make sure that as long as it is a numerical value, you have to select the scale. And if these are some nominal values such as gender or whatever, gender, ethnicity, then you select nominal, which is the 3 bubbles. Okay, now I will go to t-test, and then, okay, here in JASP, repeated measures or related t-test is, I think it is your chapter 13, if I'm not wrong. So it is called paired t-test here, paired sample t-test. So all you need to do is bring it here. I'm gonna just, okay. So one thing you remember in a t-test, you cannot compare 3 groups, okay? When you want to use compare 3 groups, you will use ANOVA. For t-test, it's always 2 groups. I have created 3 groups because I wanted to show you ANOVA. That's why I have created 3 groups, okay? So for t-test, always there will be 2 columns, okay? All you need to do is, let's say you are comparing just the low and the moderate. You just have to bring them here on the right-hand side, and then that's it. And then here, if you look at this table, you will see here is the t-value, and what you need to focus on is that p-value, okay? If the p-value is less than 0.05, less than 0.05, then you can say that there is a significant difference between these 2 groups. Now here, this p-value is more than 0.05, which means that there is no significant difference between these 2 groups, okay? Now, additionally, if you want a little more, information, you can click the descriptives, it will give you the mean, okay? So here you will see that the average, performance for those who slept for 3 hours is 4, and the average performance for those who slept 5 hours or 5 hours, it's 4.87. Even though there is a difference in this mean, but that does not mean that these 2 differences significant difference. Okay, so you have to be very careful about this particular word, which is called significant difference. You can say that there is a significant difference between 2 groups only when your p-value is less than 0.05. Okay, and here you see that the p-value is more than 0.05. So you will say, remember I asked you that write a conclusion at the end. So in the conclusion, you will say that there is no significant difference between the 2 groups because the p-value is greater than 0.05. And the mean, although the mean indicates that the group that undergoes that 3 hours of sleep has a mean of 4, and the other group that undergoes the condition of 5 hours of sleep has 4.857. Although there is a slight difference in the mean values, however, the paired t-test revealed that there is no significant difference between these 2 means, okay? Because the p is higher than 0.05. Is this clear to everyone?
Yes.
Okay. One thing you need to do is whenever you conduct this is called hypothesis testing, because you are conducting a test to compare the 2 groups. Now I want to show you something. So just compare these 2 groups because it is a t-test. In t-test, you compare 2 groups. So whenever I ask you to conduct this type of testing, so you need to follow 3 steps, okay? Your first step is step 1 is to write the hypothesis. Okay? Sorry, let me fix this. Write the hypothesis. So basically you would say, you can say it in words. You don't have to say, either you can write it as M1 equals M2, or you can write it in words, okay? So when you write the hypothesis, you have to write 2 hypotheses. One is the null hypothesis, which is actually written as HO, and one is alternative hypothesis, okay? So you can say that null hypothesis is that mean 1 equals mean 2. That means, actually it's written as not mean, it is written as mu, but I don't know, I have to go find the symbol here to find where is the mu. Anyway, forget it. So either, whoops, what did I do? all you can, you know, the best thing is either you can write mu1 equals mu2, or you can write that there is no difference between the two groups. Okay, this is your null hypothesis. Null hypothesis means no difference. Okay, and alternative, the second one is alternative hypothesis, and it is written as H1. Okay, which this means that there is a significant difference between the two groups. Okay, and this is your step one. That's it. Step two, all you need to do is you need to copy this. Where is my, okay, you need to copy this T table, and if you want, it is a good practice to present this also, because people can see how much is the difference between these two means. It's not much. So what you need to do, if you want to copy something from JASP, you click this little results, and then you can copy. Okay, and then you go to, actually you are supposed to do it in a Word document. I'm just doing it Excel sheet because I just kind of started writing it here in the same page. All you need to do is just copy and paste it. It's better to copy and paste it in a Word document, then you know everything will be aligned and nice. Okay. All you need to do in step two is copy and paste your result. And in step three is the conclusion. Means in step three, you need to write what did you understand from this, okay, from the output. From this output, you can say that there is no significant, sorry if there is a spelling mistake, I'm trying to write fast. There is no significant difference between between the 3 hours and 5 hours sleep condition, because well, you can say because the p-value indicates that because the p-value is trying to make it as explicit as I can. P-value is greater than 0.05. Okay, so because there is no difference, you fail to reject the null hypothesis. Do you agree? This was your null hypothesis, right? So that means you will accept this hypothesis. This hypothesis is true. Null hypothesis is true. So the null hypothesis is true. You can say, therefore, the null hypothesis is true, or you can say, therefore, this is the typical, you know, statistician's style of saying that, therefore, I fail to reject the null hypothesis. Okay, there is a you know, APA style of writing this. It is there in your textbook. You know, if you want to write it, you can write. You can with bracket. You can write the T value. You know, let me. If you want to. T, and then you can write this degree of freedom is the number of participants minus 1. Okay? So hold on, let me see the degree of freedom. This is the DF, which is 6. Okay, T is 0.216. Okay, I can write it as T, degree of value is 6. Just a minute. Negative 1 point, what was it, 216. Okay, and then Okay, sorry, comma, and then you write P greater than 0.05. Remember, it is greater than, that's why it is greater than 0.05. When it is not significant, P will be greater than. When it is significant, P will be smaller than 0.05. Please pay attention to this one. It's very important. Okay. So that is all for this particular repeated measures t-test. Any questions on this?
So on our homework, when we go to upload the JASP, into our homework, how do we do that?
Oh, you just need to copy this. Okay, so first of all, this is your result, right? So you copy and paste it in your Word document.
Mm-hmm.
You copy and paste it in a Word document, and then from Word document, you can directly copy and paste it on your JASP. Okay, there are two ways of doing it. If I did not give you any option to attach a file, what you can do is you can copy from the Word document and paste it in that text field which is below that particular question. And if I have given you an option to attach the file, all you can do is just attach that Word document. Please do not attach the JASP document directly, because I cannot open it from Canvas for some reason. So you can, if you like, directly save this and try to attach it to your JASP homework as a file, I won't be able to open it. So always copy the output from JASP to a Word document and then attach that Word document on Canvas. Or you can directly paste it in that area, even though that text area looks small, but actually you can paste a whole bunch of things. Expanded.
Professor, this week for the homework, I did either way. Is it okay? Because
what did you do?
There is two options. One is directly pasted on the text, and second is we uploaded the Word document. I did the two-way. Is it okay?
That's okay. That's okay. You can do just one way, or if you want, if you feel comfortable to do both ways, that's fine. I have given both the choices for your convenience. That's fine. Okay. Yes.
I thought we were supposed to do something in both boxes. So it's just an either or. We can copy and paste the Word and upload it, or the other one is to download it, correct?
You can copy and paste in a Word document and upload that Word document on Canvas as a file. There's a file option, file attachment option. That is one. The other one is copy this JASP and first paste it on a Word document. Again, you copy from Word document and paste it on the Canvas.
Okay.
Two steps. If you try to copy from JASP and directly paste it on the Canvas, I heard that some students told me that it is difficult to do that. That's why there is an intermediate step that is first paste it all on and it is a good practice, because anyway you will be writing your other things like step 1, the null and the alternative hypothesis. Then you are going to write step 2 where you are going to copy paste the output, and then step 3 you are going to write your conclusion. So you can finish everything in a Word document and then copy the whole thing and then paste it if I give you that text area, or directly attach that Word document on Canvas, or do both. Is that clear?
That's where I messed up. Last week's homework, I didn't do the JASP because I was trying to upload JASP itself onto the homework and I could not figure it out.
Oh, I see. Okay.
And Professor, okay. This week I pasted the 3 steps on the text box. For the Word document, I only pasted the result. Is it okay?
That's okay. That's okay.
Oh, thank
As
you.
long as I, so from next time, do everything in one place so that, you know, it'll be easy for me, but yeah, that's fine. You know,
Oh, thank you very much.
it's just the starting for you guys, but you know, since you did it, that's fine, not a problem. And one more thing, we just did the repeated measures, right? I will quickly show you the independent group. The independent group design is slightly tricky, okay? So let me just quickly close this one. Save. Okay, so now for independent group, oops. I hope I didn't mess up anything. Okay, what did I do? Hang on. Can you see my screen?
Yep.
What is going on? I have no idea. Okay, anyway, so this is an independent group design. What I did, okay, first of all, let's look at this. Here is the question, okay? So when I give you the question, they will look like this. So there are 3 groups, okay? So the hypothesis, well, the problem of investigation is that the researcher wants to see whether exercise leads to weight loss, or diet leads to weight loss, or it's the combination of exercise and diet that leads to weight loss. Okay, so these are the so there were 3 different groups. Remember, in independent group, what happens is there are 3 groups. Okay, 3 different groups. So this is one group that only did exercise. This is group 2 that only did diet, no exercise. And this group did both exercise and diet. Then, so the researcher measured the weight of each participant. So there are like how many participants? 1, 2, 3, 4, 5, 6. There are 6 participants in each condition. And remember, these are 6 different. These are 6, this group is different from this group. So there are 6 participants under exercise, another 6 participants under diet condition, and then another 6 participants in the exercise plus diet. Now, if you want to conduct an independent group t-test, you have to kind of change the layout, how you set it up for JASP. If you set it up directly like this on JASP, then JASP thinks that this is a repeated measures design. Okay, so for JASP to understand that it is an independent group design, you have to change the layout. So what I did was, I first copy and pasted all the values for exercise. Okay, so this is my exercise group. And below that, I stacked the values for the diet group. So basically, I have 2 columns. First column has these 3 groups, okay? All the participants of column 1 first, and stacked below, I did all the participants for column 2, and then column 3. And it means the same thing, it's just the layout. And this is what JASP wants us to do. Otherwise, JASP won't run that independent t-test, okay? So you have to basically shuffle this whole data set and set it up like this. There has to be just 2 columns, okay? One column is this group, and the other column is the dependent variable, or the numerical variables. So this is the same thing I have copied and pasted here, okay? Now, and then I saved it as my independent group measures with the extension of CSV, delimited. Now what I'm gonna do is I am going to just close this. There are too many windows open in here. Okay, discard. Okay, so what I'm gonna do is I'll just go here, open my computer, I'll go to downloads, and then I'm gonna look at the independent group. I'm gonna open the independent group, okay? I hope it'll open up here. It takes a little time, or I don't know what it does. It somehow doesn't want to open it so easily. Okay, maybe it's opening, it's taking its own sweet time. Okay, there you go. So it has opened my data here. So now what I need to do is I will go to t-test, okay? And see, there are two options. We already have done the paired t-test earlier. This time we'll do independent t-test, okay? So for independent t-test, so, okay, now you have to understand the difference between this variable and the grouping variable. Can anybody tell me which one was my grouping variable? It was those 3 groups, remember? And I called it a lifestyle. Do you see this? Hold on, where is my other one? Okay, this one, no, where is it? So I called this group as lifestyle. This is the title of this group, and this one, this is my weight, okay? My dependent variable. This is my independent variable. So this is my group variable, okay? Because these are my groups. And these are just a variable. Variable means dependent variable, which is the outcome. And these are the groups. Now, same thing here. So my group variable is lifestyle. It'll come here, and weight is my numeric variable. Following problem of running the analysis, the number factors. What happened? I'm not sure what happened. Hold on for a second. What really happened? Number of factors level is, oh, I see. What the problem is. In a t-test, you cannot have more than 2 groups, remember? Let me remove this. Oh gosh, okay. In ANOVA, you can have more than 2 groups. It has, okay, let me save this. Yes. Now, okay, so. If you want to see your data, all you need to do is, sometimes it works really well when you kind of pull it like this. Now I remove the 3rd group. In a t-test, always remember you cannot use 3 groups. It has always 2 groups. 2 groups. Only in ANOVA you can do 3 groups, and the procedure is same. So now what I'm going to do, this looks fine. So now I'll just do it again, just to reset. Okay, this should work. Okay. Oops, what happened?
Lifestyle was the group variable.
Yes.
You're doing it backwards.
But you put the weight.
Oh, okay, sorry. Yeah. This lifestyle should be, thank you. I'm trying to kind of, okay. One came to the room and I got distracted. Anyway, so here it is. Do you see this p-value? Now, if you want a little more information, click this and you get this. Now, do you see, again, there is no significant difference between the 2 groups, diet and exercise. Let me do something. Let me go back to make your results a little interesting. Let me remove the diet, replace the diet with just exercise plus diet, okay? Control V. So now I haven't saved that data. So far we are comparing diet and exercise, and you see that p-value is not significant because it is greater than 0.05. Now what I did here is I just wanted to show you how it looks when there is a significant difference. So I replaced the diet part with exercise and diet, and I'm going to save this. Yes. And then what happens when you save it here, I think it automatically saves here. Here you go, it's saved. Now, see, instantly it runs the analysis, and now this is less than 0.05. Less than 0.05 means that there is a significant difference between the exercise group and the diet plus exercise group, okay? And then additionally, if you look at the mean, you see that the exercise group and here, The mean weight of diet plus exercise group is 125 pounds, and the mean weight for exercise only group is 151 pounds. Again, this is all hypothetical situation. This is not proved by any research. I'm just creating it as a sample for you to understand how to run the independent group t-test. So all you need to do is you need to copy this and then just click this. Sometimes if you have too many results, suppose you just want one part, all you need to do is then just click this and copy, then it partially copies whatever you want. It doesn't copy the whole thing. Anyway, again, you have to go through the same steps. There will be 3 steps. Step 1, you're going to write, a null and the alternative hypothesis. The null hypothesis is that there is no significant difference between exercise and diet plus exercise. Then the alternative hypothesis will be that there is a significant difference. And that's your first step. The second step is going to be that you are going to copy and paste this in a Word document. That is your step 2. And then in step 3, which is your conclusion, okay? So can anybody tell me the conclusion? I mean, it's okay if you go wrong. Do you want to or you don't want to? No, you don't want to? Okay. I can write the conclusion for you here. I'm just writing. Can you help me at least? What do I say?
So the conclusion does have a significant difference because it is lower than 0.5?
Thank you. There is a significant difference because it is lower than 0.05. There is a significant difference between the exercise and the diet plus exercise group as P is less than 0.05. Okay, so you can write it in APA style. Usually in APA style, what you can do, if you write in APA style, then you don't have to say as P is less than. You can simply write like this, T, and then this is your degree of freedom. Let me see, where was my degree of freedom? My DF is 10.
Yes.
P value is 2.794. I can write T. Sorry, I missed, what was it? Was it 10 or 9?
10.
10 and 2.794. T. You can say just 10 equals 2.794, comma. Now P, you have to write less than 0.05. Okay, and then you can say, I reject the null hypothesis. Because your null hypothesis, remember, is always, it predicts that there is no difference. Okay, so I reject the null hypothesis. Of course, you have to write step 1 and 2. This is just step 3. Okay, so this is how you are going to conduct your t-test. And I can show you how to conduct a correlation. It's very simple. All you need to do is, let me see if we have the data here. Oh, we have this practice data. So, there is one way of doing this correlation. Here, if you see this, it is called correlation matrix. You click correlation matrix, and suppose you want to see the correlation between age. Correlation is always done for numerical variables. You cannot do gender, the nominal variable, okay? It has to be numerical. So you bring the creativity skill here. It quickly gives you this table, okay? So, well, it is thinking, it's taking a little time. Usually it doesn't take that time, but yes. So here is your R. R is the correlation value. Again, look at this p-value. It is not significant. There is no significant correlation. That means there is no relationship between age and creativity, because see, the p-value is greater than 0.05. Okay, you know, again, is there anything, if you want to kind of sometimes plot, if you want to plot the you know, you don't have to do this. This is good enough, actually. And that's it. It just says there is no significant correlation between, say, these two variables. Again, you will have 3 steps. Step 1 is there is no correlation, null hypothesis and alternative hypothesis. You will set up your null and alternative hypothesis for step 1. For step 2, you copy and paste this as your result. And then step 3, you just write your conclusion saying that there is no correlation between these 2 variables. And it's the same thing for ANOVA. ANOVA, of course, for ANOVA, you will use 3 groups. Whenever there is more than 3 columns, you use ANOVA. Okay, so this normal ANOVA is independent group ANOVA, and then repeated measures ANOVA is the other one. You don't have to do repeated